Thank you for the kind introduction, and I'm delighted to be here on Valentine's Day. The next two talks are very well coordinated, so you'll feel the love of NetFlows, and particularly visualizing NetFlows. It's a really hot field, and these are only two of the tools. There's probably about a dozen tools out there, so maybe each individual tool is a little different, but I think the consensus is there's something to this. If a little bit about NCSA is we are an edge network, and we sync a lot of traffic to people that run our CPU cycles that do large problems on our supercomputers. So this is an edge network that's coming into the ISP domain. But we've worked with our tools are used by large edge networks that have multiple, let's say, Class B IP address spaces. So they're starting to. These tools I'll be discussing looks like they'll be very amenable to an ISP environment, and I'll ask for your feedback about that as you begin to use them. So this is a brief overview of the talk, and of course we won't be able to discuss everything about these tools, and I have a list of references at the end, and these slides are online, and you could contact me. And the tools themselves are freely available on the internet for the executables downloadable. We're going open source, but it's not there yet. So the URLs will be listed in the slides, and you'll see them. So first, I'll talk a little bit about why we went this direction, and a little bit about the love of NetFlows for security in particular, and then the brief description of the two tools to give you an overview, and then a summary. So the motivation is, I don't think, when I came here I wasn't sure of how many people were onto the NetFlows for security, but after seeing the intro to security talk and hearing the security BOF, people are using NetFlows for security in this community. Some of the other communities that are at the forefront, like say the FIRST community, was one of the first communities that saw the power of NetFlows for security. Particularly, you don't need to be told that you live in a large environment. I mean, large in multiple senses. You have a lot of objects you need to manage, and you have large volumes of data. So you're not really you're not looking for data. You have more data than you can handle. And then this data itself is complex. Let's just say each type of log has records, and the records each have multiple fields, and the combinatorics blow up if you look at all the relationships between all the different fields. So let's just say you solve it. You find out what's happening in one instance in time. Well, the devil's in the details. Things change quickly. You have time dynamics. If things are changing, it isn't static. So this is a difficult problem. So visualization can help. Visualization basically is just a representation of data in a different domain. And humans are particularly, this is the way we learn. I have two young children, and then I can see if they learn visually. So our brains are geared toward real-time processing of visual data. So let's leverage this for our network management domain and for security. And in another sense, we don't want to reinvent the wheel. There's a lot of people who have been studying this in psychology and human factors, human-computer interaction. And one of the paradigms the consensus is that you want to overview the data, get as much data as you can in front of the user, and then allow the user to interact and browse with the data, and then have the user interact and dig down for details on demand within the data. So this is a sort of a mantra that's come up within the human factors, human-computer interaction field, and that's a little bit of behind our design of our tools. So if you allow me, I'll do the love for NetFlows for security in a little particular. I think everybody use NetFlows for security in different ways, but I just sort of put a laundry list of ways that we use NetFlows for security. So in particular, NetFlows are connection-oriented statistics. So you know who's source-destination pairs, and you know like what services are using and when the timestamps and when it happened. The question is that what kind of things can you identify with this? You have IDS alarms that, particularly the signature base, that look in the data field. So NetFlows in particular don't look at the data field. You can configure different types of NetFlows to do that, particularly Argus. I know University of Chicago was enabling the Argus type of NetFlows, or different forms of NetFlows, to look at the first 64 bytes of NetFlows of a data packet to look at this. They thought that 64 bytes you can actually identify a lot of things just in that little bit of space. So, but in general, most people don't use the data field. So the connection-oriented things you'll see are like high byte transfers for DOS attacks, or things that are like doing like laptops that are transmitting a lot of information that typically shouldn't be doing that, or connections. A lot of attempts that would happen from machines that you wouldn't figure should be doing that. So that's probably the highest value. But then there's a whole bunch of other ones, like how many users are on your network at a given time. If you're an ISP, if you're going to be making some changes, you might want to do it, maybe in the middle of the night, of course, but you may want to look and see on your network and see the activity and sort of get familiar with the behavior. Who are your top talkers? This is a common one in many places I've worked, and in many places I've observed. All seem to have a list of people they expect to be top talkers on the network, and then when a laptop shows up at the top or something drops out of the top 10, it's something to investigate. And how long do you look at long-lived connections? You sort of have a feel for who's doing what in your network. So all these things, I'm talking from the edge network, but you can transfer this to the ISP domain. Where do people go, and where do people come from? So in an ISP domain, you want to see like what the dynamics are. If they're watching the CNN and the Olympics, you can probably see that traffic on your network. And are users enabling services that they shouldn't be doing? Or they have had just some discussion earlier about open relays or different peer-to-peer activity. You can definitely see that in NetFlows. In particular, like on our network, we're looking at what destination ports people are trying to probe. In particular, the particular reason, if you know there's a vulnerability out there that's been announced, maybe not patched yet, you might want to keep an eye on that activity on that port to see if people are trying to probe a port for vulnerability that you know about. And lastly, I'm sure most of you have blacklists of either hosts you know that are malicious or domains that you're suspicious of, or hosted or continuously compromised. You keep track of these, and you can look at these in your NetFlows. So this is a laundry list of things you can do with NetFlows. It's not everything. It's meant to be a complementary tool to, let's say, your IDS infrastructure, maybe your syslog infrastructure. But it's definitely, there's a conciseness and a way to represent this data. So this is value just in the pure raw data, whether you use ASCII or you manipulate it in binary, grepping on your. So we're going to go a step beyond and look at NetFlows for visualization now. So this is more pertinent for the edge network, but there's different ways of getting your NetFlows. I'll just say that we get our NetFlows from our Cisco routers, and we distribute the routers and aggregate them. So we're not always trying to get the NetFlows from our border router. Particularly, there was a CPU hit, and as you get to, let's say, 4 gigabytes and above, a lot of routers don't even support raw NetFlows. They want a sample, and for our domain I'm talking about it for security, they really don't want sample NetFlows. So you want to distribute your collection ability and then aggregate these NetFlows and merge and delete duplicate NetFlow records and things of that nature. We also deploy the open source Argus for NetFlows, which is a sensor you can put on a PC. You can gather the data. It probes all over your network, and they're different. I mean, so in one sense, Argus and Cisco NetFlows add a lot of complementary power. So Argus is bidirectional, Cisco is unidirectional. Let's say there's cache configurable. You can set the caches. Let's say you can set the Cisco default is 30 minutes. We set our Argus default at 1 minute, so you have different views and different time frames. So this is a little bit. We could go into detail and look at some of our papers about how we use the power of NetFlows to instrument it of a network. So those would be a little bit different. We like to see how people instrument their NetFlows within their ISP. Okay, so the meat of the talk now is about these two different tools. So I don't have a lot of time to go over the details of all these tools, but I'll show you the picture. The pictures are worth 1,000 words, and we have some papers to describe the use, sort of like manuals to step you through if you download the tools and want to see how they work. So the two tools are NVisionIP and VisFlowConnect IP. So there's the URL to download this tool, and there's a description of the tool with that address. Okay, so, whoops. This tool is a 3-level tool. So remember the mantra that's come from the human factors community is you want to overview first, then browse, and then drill down on demand. So it's a 3-level tool. So the first level we call the galaxy view, which is the lowest view, and that actually shows you an overview of the network. And then we have like we call the small multiple view, which is really the subnet view that you can actually scan your network. And then if you identify a particular host you want to look at, we have the machine view. So at first you have, let's say, the overview of your network. Basically what this is I'm not so sure if you can see in the back, but there's a screen with a square in the middle, has dots on it. And each of these dots represents an IP address. The color and the shape of that IP address is settable by the user for different parameters. Let's say, particularly the first intuitive thing you might want to look for is what the byte transfer is in and out of each IP address, and what the connections per period of time for an IP address. So you can set like high byte transfers and high connections over a period of time to, let's say, red, and then have that shape be like an exclamation point or whatever. So there's only so many things you can do with NetFlows. I mean, there's a finite number of fields. So in particular, the user can set what they want to look for as far as protocols. You can look for all protocols. You can just drill down for TCP, UDP, ICMP, etc. You can look for different port activities. You can look for all ports. You can look for specific ports or a range of ports. And you can look for, let's say, the number of bytes or number of connections per period of time, and we've already mentioned that. And then you can also look for, let's say, everything, or you can look for just sources, just destinations, or any combination of the two. So what we've done is hard-coded anything you could think of an SQL query to a database and hard-coded it into this application. The reason we've done that is now it's optimized, so you can run these queries real fast. We don't think it's really a good idea to, like, say, take your NetFlows and always load it into a database. So that's an approach that some people do, but we find that it depends on really your network. If you have a network that you can scale and you can load it all in a database, that's fine. Well, we use this tool. We can actually use the raw NetFlows, load them into this tool, and we don't have to worry about the scalability of a database. So we have an animation toolbar, so you can actually see how the NetFlows change on your state of different IP addresses on your network. We have an animation toolbar that goes in time. We have a clock that shows us the time passes and a timestamp. So this is the overview of your network. So as you can see in the back of the room, you can't even see, we have a magnifying glass that's part of one of the widgets attached to this tool. But in general, this is an overview, and it can use to give you context of what's going on in your network. And we find that you can identify things very easily on our edge network. We see our clusters pop up and where our servers are placed. But in particular, you might want to drill down, and you interact with that using a mouse to see, okay, I want to see this part of the network. Then you'll get what they call the small multiple view, or the domain view. And what that allows you to do is much like a stockbroker would like scan the Wall Street Journal to look for like they call them spark diagrams to see how stocks are going up or down. You can browse over your IP address space and see. You can highlight different ports. That's what the legend is on the left with the different color codes, and see, like, you can look for let's say mail servers, or you can look for like telnet, plain text password things, or you can look for any type of service. You can just put it a color you like, and then scan over the IP address place. It allows you to go over your IP address space and scan for different things. Notice there's no annotation. There's no numbers or words on this. It's meant to just be a browsing tool. Then so this is saying that what I just said. So each diagram, each block in there, it may not show up in the back of the room. There's sort of like a rectangular block where you see these histograms. Each block contains an upper histogram and a lower histogram. The upper histogram is activity on well-known ports for that IP address, and the lower histogram, which is typically in blue and gray, represents ports over 1024. So you can identify well-known ports by their colors, and then the port distribution of the ephemeral ports above 1024. That you really look for a distribution. So that you can see how this you're going to be allowed to scan over your network. And then you identify, let's say that particular IP address looks interesting, then you can go down to the machine view. In the machine view there you have multiple things. At the top you have tabs that allows you to look at different dimensions. Like I said, NetFlows has a finite number of fields. So you can look at, say, traffic for protocols, traffic for ports. And the top part of this machine view allows you to look at, let's say, the aggregate traffic both in and out of that IP address. Again, using that same concept where you have the well-known ports and the histogram at the top, and the ports over 1024 below that. And then you have two sets of histograms on the other side showing the traffic sourcing from that IP address and the traffic syncing that IP address. So You can see how this could be valuable if you want to see, quickly scan your network and find out particularly what's going on in an IP address. And you can also drill down and actually see the raw net flows from this view that are associated with that IP address. So that's this tool, NVisionIP. It's meant to be a tool that looks at the state of IP addresses. It's designed for a Class B, so we know, let's say, campuses that have multiple campuses, like the University of Illinois, where NCSA is based, has multiple campuses. We have multiple views of this for each campus. Or you can, let's say, University of Minnesota, I know, has multiple Class Bs. You can have a different instance of this for each of your Class B addresses. An ISP has, many Class Bs, or Class Cs. You can actually use this for ones you want to drill down on. I'm not quite sure how an ISP would use this, and it would really depend on the size of your ISP to use this, and that's what I'm here to present to you and see if people will be interested to share their experiences. The next tool is VisFlowConnect IP, and I'll briefly go through this tool. Again, the pictures are 1,000 words. So one of the things that happens is when you design a tool, you want to put everything you can in it. So we tried to actually show not only the state of the IP address, but who was connecting to who. It got too much, and we work with people, and it's doable. We actually work with Stephen North of AT&T, who designed GraphViz, and that some of you are familiar with. That's what AT&T, the base of their tools to look at all the traffic when AT&T was, the only way you can do international or national traffic, right? They were Ma Bell. So we feel like we had a pretty good view of this, but we were just too much. If you have too much data, it obscures what you're trying to look at. So what we did is we separated out who was linking to who from the state of the individual IP addresses, and the link analysis actually turned into this tool, VisFlowConnect IP. Okay, so the basic paradigm is you have 3 vertical lines, and again we're coming from the edge network. The middle line is actually the edge network that you're trying to manage, but an ISP can actually put this as your ISP. You can set up a range of addresses you're interested in looking at. So the 2 outer lines represent outside domains that are sourcing or syncing traffic to your edge network. So the convention is from left to right. From people in the audience, I know if this is being broadcast over the internet, the line from an outside domain axis on the left to the middle line means traffic sourcing into your network, and then traffic from the middle line out to the outside domain on the right means traffic sourcing from inside your network out to the internet, or for say if you have this at your border router. So it's sort of intuitive feel. You see lines, you see traffic coming in, traffic going out, and typical question like a network manager would say, like, what's happening in our network? Well, here's traffic going in and traffic going out. Typically symmetric. We've sort of alarmed it so if there's asymmetric traffic flows that we have that alarmed, and you can see that in particular. So of course the time domain comes back and bites you again because the traffic changes, and depending on how you aggregate the traffic, you're going to obscure traffic. So that's what we learned from the GraphViz people at AT&T, is that if you're trying to show everything, you're just going to have a big blob there. So what we've done is created a time window that it's configurable by the user, and the traffic's only shown that it's within that time window. And the time window goes across the tool, and you have VCR controls at the top that allows you to, let's say, go back and forth. You actually load a log file, and you can go back and forth with a VCR and go back and forth in traffic and see who's connecting to who. You have a clock and a timestamp, so you have exact time, but also human intuitive time. And you can highlight different ports to see port activities. The one thing this doesn't allow you to do is actually you want to if you want to just scan all the port activity. I think the next tool that'll be shown is the Flamingo tool. Actually does a good job of that. This is highly scalable, so we don't keep port information because of the combinatorics of that. But if you know what you're looking for, you can find it here. If you don't know what you're looking for, you're going to have to use some trial and error to find it. You might want to use the other tools, particularly this Flamingo. That'll be the next talk. So let me just show you some quick examples. So first thing is, if you notice in this previous picture here, I mentioned this is outside domains coming to your network. So as you said, we did some testing, and we found that like over 100K hosts in a typical time period we want to look at can't scale on a screen. So we can't really list all outside hosts coming into our network, so we just put domains. But it turned out to be really useful for security because a lot of times you have attacks, it's multiple hosts within a single domain. So it seemed to be scalable in that sense. So what we've done is, when you have a particular domain to see activity that's interesting, you click on that domain, interactivity, you drill down, and you have a domain view. So now you have all the different IP addresses in that domain are now visible. I'm seeing this is not showing up that well, but you can take a look at the slides if you want to download this offline. But basically, what it is, it allows you to see activity from domains into your network, but also individual hosts within a particular domain you specify. So this doesn't show up too well either, but this is MS Blaster. If you want to show like a scan of a worm or some scanning activity, it shows up pretty clearly as a point on an outside domain or an outside host hitting all the IP addresses on your network. So in particular, you have to know the context of what's going on within your particular network, edge network or ISP. So sometimes a scan isn't always a scan. So here you see multiple connections from one domain, or in this particular one host is scanning a portion of our Class B address space at NCSA. I mean, what is it? Is it a worm? Is it somebody like doing a vulnerability analysis to see if it can do things? So we looked at this particular one, and we graphed it within the domain view, and we found out it was consecutive IP addresses from the outside, looking at consecutive IP addresses within NCSA. And that's sort of unusual to see a scan that has that characteristic. And we looked a little bit closer, and it's IP addresses at Caltech, and it turns out that the IP addresses in NCSA were a cluster. Well, it turns out it's a cluster at Caltech. It's grid to grid, it's grid communication, cluster to cluster, where actually our clusters at NCSA are internet accessible, so they're actually running parallel jobs over the internet. So sometimes a scan, it might appear to be a scan. This should give you a little bit of situational awareness and know what's happening. Just because you have some characteristic that looks like an IP address hitting a bunch of other IP addresses doesn't necessarily mean it's a security event that you're trained to look for. So the next one is we have a lot of hits on particular IP addresses at NCSA. So we were like, this is a particular characteristic pattern we see many times. And we noticed that these are all our web servers. And then we looked at these, and these are web crawlers, particular, I won't tell you what company. But, so we see this happen during a part of the day. So we're starting to see activity using this VisFlowConnect of who's doing what on our network in a sort of an intuitive way. And I can show this to my boss, and my boss says, oh, yeah, okay, I understand that. We have grid commuting. We have the crawler sending our network at a certain time, and then a picture tells 1,000 words. So it's not just activity coming into a network and going out of a network that you might want to look at it as an ISP. Is also we can look at internal traffic sourcing and syncing within one network. So this might not actually be the case of an ISP unless you have like multiple parts of the same organization that have the same address space that would be going over an ISP's backbone. But in particular, NCSA, we look at all our traffic within the network, and this is much more clear that you can see. Let's say one user is looking at different. I don't know if there's a scan activity or somebody's doing some activity on one of our clusters with hitting up a large part of our address space. So this is our tool, VisFlowConnect IP. Hopefully it's intuitive, and the URLs are there, and I'll show you the references in a second. So in summary, there's a lot of activity going in this space of not only using NetFlows for security. I think we're past that. We know that works. But now visualizing NetFlows, because they're voluminous, they're high dimensional, and humans, in some sense, we're trained to look at text files and do things with binary files. But we're not. That's actually not how we're hardwired when we're growing up. So why don't we sort of leverage our human capacity? I've set up a discussion list for the flow analysis. I think there's multiple of these flow analysis lists. This is one that's linked with the FlowCon community. The CERT-CC has had a couple conferences on flow analysis using NetFlows and other type flow statistics, S-flows, whatever, for security. There's the URL, and go with the flows. These are the two tools. I have a list of references. They'll bore you to death if you want to. You see that we actually went and talked to security engineers to get their mental maps of their conceptual views of how they want to look at this data. So we didn't just design the data from scratch. We actually had this luxury to be able to design from scratch. So we have references listed on the slides if you want to print those out. And there's the URLs. So invite any questions at this time. I don't know if anyone's visualizing NetFlow using other tools. I saw FlowScan was shown in one of the other earlier slides.
Yeah, and just while we're waiting for the while we're doing that, Manish, if you want to bring your laptop up and we'll swap that in to avoid the latency. Let's start in the back with the inimitable Avi Friedman.
Avi Friedman with Akamai. I actually don't have a question about the visualization tools, but I wanted to let everyone know that you mentioned Argus a lot, and it's a toolkit that I'm not sure that people in the operator community are familiar with. But not only does it let you grab NetFlow data symmetrically, it also gives you a little bit of performance information. So a little bit of the TCP statistics, loss, latency. So if you're looking for justification to deploy wider NetFlow instrumentation, you can actually get some performance data as well. And I don't know whether there's any play with the tools that you're working on at looking at the performance impact of flows and correlating that. That's something that I know some people are doing just with back-end, text-based tools. But Argus is a very interesting gathering mechanism for gathering data that I encourage people to check out, and it's also very efficient.
Very good point.
Hi, Roland Dobbins, Cisco. Yes, you're right. A lot of people are using various open source and commercial tools to use NetFlow for security analysis. I had a comment, just so that you know, at least in our implementation of flow telemetry, and I'm sure other vendors have as well, we have both ingress and egress NetFlow capabilities now. Perfect. So you made mention about unidirectional. So it's certainly possible to do ingress and egress depending on what you're doing at what portion of your topology. And I had a question for you. I had looked at this tool before. Some of your visualization stuff, with the waterfall displays and stuff is pretty cool. In reading the paper that described it, and there was an allusion to it on one of your slides, it seems that there's some data conversion required once the flow telemetry has been collected, that it then has to be converted in maybe a batch manner into an internal format that NVision can understand. Is that correct?
Yeah, so maybe I wasn't clear about this. Right now we don't have this enabled for streaming. So we're reading log files, and the log files we use are 5-minute log files. Of course, when, I know some people say, okay, that's offline processing, but I mean, if you're looking for security, 5 minutes is about right, because humans really don't act on millisecond time frame. Well, so the other thing we do is you talk about different formats. So let's say Argus. Argus, it depends on how you configure Argus. The readout you get from Argus is not standard. It depends on how the user sets it. So we actually set like standard formats for, say, for Argus and even for NCSA. We have a tool that you can use to convert any version of NetFlow. Well, version 5.7 Argus NF dump tools. We have another tool called Canine that actually does anonymization also that does that. So the reason why we do that is that people have designed different tools just for their data source. We're trying to make our tool independent of that. So so as far as the processing goes, there's internal processing in the tool itself that actually bins the data per IP address for NVisionIP, and it actually gets streaming statistics for VisFlowConnect. So VisFlowConnect is more scalable. We don't keep any state. NVisionIP has to keep state because that's actually what the tool represents. So what else can I say is that so there is some internal format, but there is also an external format issue too.
Right. So is the 5-minute bin, is that hard-coded, or can you manually adjust that depending on how much processing power you have available to do the conversion, and then you adjust your flow timeout values on the routers and other export devices accordingly?
So it's completely user settable. So that's an NCSA. When we set it for our organization, you can set it for anything. We found that there's a certain limit, though, if you have a large file with a lot of traffic. If you want to read in a gigabyte a log file, it's going to be much slower than if you read, let's say, a megabyte log file. So you scale it for, and then we actually open the file and go into it and read it, open access to the file and read it. It's sort of a streaming nature. So that's how we can actually navigate in that file using VCR controls. So instead of trying to read in the entire file, you open access to the file and read it a little bit, and you can navigate through a large. So we can read large files, but there are performance hits depending on the size of the file. The size of the file that you want to look at is completely independent. So user sets what they want. You can read in any size file to NVisionIP.
Gotcha. And one final question: are you planning on doing any further work on this tool to perhaps make use of the TCP flag information that you get from flow telemetry, fragmentation bit, drop traffic statistics, things of that nature?
It's a good question. So we've looked at that, and right now we're really relying on tools that are more IDS based to look at let's say flag type things. You're looking for different patterns in the flag activity. Right now we're not really looking to visualize that now, but that would be something that if you use the tools, you can actually look at the raw net flows, and actually you could alarm on that. But that's we're not really looking to do that now. But it's a good question.
Thank you very much.
Sure.
And last question, because
Hi,
Jerry gave up.
Render, River Domain. I just want to echo what gentleman said about the Argus. Also on this gentleman's comments about setting bits, are there any provisions down the path of setting priorities on certain traffics or dropping certain traffic down depending on a spike on the network. Like, for example, if you're seeing a tremendous amount of traffic coming through, I mean, I understand it's
Sure.
a network monitoring, but it'd be cool to have some sort of a provision where you can kind of drop the priority on the traffic and kind of rate limit, if you will.
So there's filter capabilities, like the user can set. So if you know what you want to filter, or you have ideas about what you filter, the user can set, and you can, you want to drop all your normal traffic and just look for things that look like things you want to investigate. So the one thing what you're alluding to is
He actually
automated.
meant kicking off, kicking off rate limiting.
Yeah. So that's really a tough problem. If you want to automate this tool, you're trying to get an expert system to what security engineers can do. And we're trying to do that, but it's difficult. We have one idea called closing the loop, what actually goes back and takes feedback from the user that's using this tool and goes back and changes what the source data they're getting depending on what the user interacts with on the screen. Like using your visual interaction with the mouse, you can actually say, okay, I want to look for this type of NetFlow data, and then you would actually gather different tool. It's a difficult problem, right? That's like an open research problem now. But I mean, if you do that, that'll actually one of the things that people, there is a trade-off here. If you start alarming the visualizations to say, okay, here's an arrow and it's blinking and it's red, saying here, this is something to look at, then what it does is it takes your attention away from the screen of the wider information. So then you might, if you know what you're looking at and you use machine learning algorithms to do that, you might as well just be using an IDS. This is more of a wider tool that allows you to look at your environment, and then you can actually use this complementary with an IDS that you can alarm. So the alarm says, okay, here's something to look at it, and then you can look at the screen that shows you the pure traffic. What the HCI people tell us is as soon as you start alarming and focusing users' ideas or vision on certain things, you're obscuring other things. If you're 100% accurate, that's ideal. But we find that the IDS is nowhere near 100% accurate. They're inaccurate. They're false positive rates. So we don't want to do more harm than good. So what we're doing is giving the pure data, allow the ISP engineers like yourself to be able to see the raw data, visualize the raw, transparent. We're not changing anything, and then you can interact with the data filter in different ways. So it's a great question to ask, and hopefully I've communicated.
Thanks. Thank you, sir. Sure. Thanks very much.